This conference will now be recorded.
So that we can switch to the topic called files, actually one more important topic in Python. So that is also very important topic. So let's see. Let's first of all finish up this, okay, and then okay, let's see this now. Okay. So if you see, this is all we had discussed in last session. Default parameters, variable length. We have discussed about types of parameters. And returning, we have discussed how to return a value. Then types of variables, local and global. We have discussed both parameters. So both type of variables. The next topic is recursive. So what is this recursive functions? So this is one of these are very useful functions. The advantage of recursive functions is they are used to implement recursive calls, like a function which calls by itself. That's what recursion is. Where can we use recursion? Generally, when you are implementing these algorithms, like sorting, searching, okay, or any other such kind of algorithms. So recursion is one of the very useful approach of implementing that algorithm, because this looping you can do without using this. What is that? Recursion is like a kind of looping where we can implement a logic without actually applying an actual kind of loop, like for loop or while loop. Or like that. Okay. So this is a simple thing. What is this exactly? What is recursion? A function that calls itself is known as recursion. So far, what happened? If you are talking about a function, we call function from some scope. Usually that is main scope. Yesterday we have written some programs. If you see, so this is a call. If you look at this, these are calls and these are functions. And these callers, wherever you put, they are under a scope called main scope. Means they are inside some main function. You can ask me a question. Like, I didn't see any main function there. Then how can you tell that they are inside main function under main scope? See, by default, any statements which you keep in your Python editor will be automatically put into a main function, put into a main scope, put into a main method. Instead, you don't need to declare main here, like in C, C++, Java, C Sharp. Behind this, there is main. You don't need to worry about it. What are the statements you write, except for other than the functions, they are always put into this main function. If you don't If you don't, what is that? Get satisfied with this statement, you can prove it also. We just check that also. Okay, so probably I'll do one thing. Hope I have installed PyCharm. Or I might download it. We can see that there also. I'll show you. But meanwhile, remember, other than this statements in the function, remaining all independent statements, they were in main scope. These kind of statements are in main scope. I will show you very clearly. Nothing to worry about. Next one. And I'm switching to the topic. So that's the idea about what is the point here is. So point is what these statements. What happens? You make a call from this caller. The control will jump from here and go to the function. Okay, execute that, and the control come back. So this is actually non-recursive function. Means what's happening here is there is a frequent control jump from caller to caller, function and function to caller. Okay, there is a frequent control jump. Suppose I want to find the factorial of some 5, then what is that? If it is a non-recursive function, you have to either put a loop inside. Otherwise, otherwise what? There should be a frequent control jumps from calling function to the called function, and from called function to the calling function. This is this F1, F2. We can call them as calling functions. Okay. So the point is simple here. What is that? If it is a non-recursive function, we have multiple control jumps from caller to calling function and calling function to caller. Calling, understand? Okay. But whereas in recursion, you don't have that. Okay. You don't have frequent calling jumps from excuse me, from caller to called function and called function to caller. Following? See, here, when you call it for first time, the control will jump from caller to the recursive function. From there onwards, that recursive, as name says recursive function, the function will call it by itself until the whole execution, the business logic is completed. We call this function from outside externally only for one time. But from there onwards, there will be internal call to that function. It will call by itself. So that is recursion. Okay. Now we'll see an example. The advantages are we can reduce the length of code. You don't need to write very lengthy code with recursion. Second thing is we can solve certain complex problems with recursion. Okay, it's easy to solve this complex problems with recursion. Okay. Next. Let us see a small example. Factorial. We have done this factorial program somewhere in the beginning of our program. Suppose if I want to find factorial of 5, it has to be what? It has to be 5 into 4 into 3 into 2 into 1. You can do this by putting a loop. You can do this by using a small loop. That's also possible. That is one approach. There is another approach. We can do this factorial with recursion. Not just factorial. Many algorithms we can apply with recursion. The most complicated algorithms like say, sort, selection sort, bubble sort, or many other sorts. Not just sorts, even searching. Okay, right. Many data structure algorithms can be implemented with the recursion. Okay, so fine, let us understand this then, how it works. So here, just yesterday we had discussed how to define functions. This is not something too difficult. It's a simple and easy function. So here, what you have to do is just define a factorial, and one parameter is required to find the factorial for a given number, that is n. N can be anything. It can be 4 or 5 or 6 or 7 or 8, whatever it is. So point is, what is the point here? N is nothing but it takes a number, and for that we should find factorial. And what we have to do is we have to apply a condition check here. What's the point is if n becomes 0, then you should return 1. No, 0 factorial, right? You learned in mathematics somewhere in school days. What is 0 factorial? Do you remember? 0 factorial is 1. Yes, sir. I'm not that, I'm not a great mathematical guy, but I still remember. 0 factorial is 1, right? Yes, sir. Do you agree? Yes. Here also it is same. What is that? Here also, if n is 0, then return 1. Because if you don't return 1, if n becomes 0, then your whole result becomes 0. There is no point in working with factorial program. Okay. So once n is 0, we should stop the iteration also. Suppose I pass my n value, so to this function I pass my n as 5. If I pass n as 5, then 5 into 4 into 3 into 2 into 1, I should stop after 1. Suppose if it is 0, I should return 1 then. Okay, then after I should stop after that. So if n becomes 0, you return 1. Else what I have to do, I should apply iteration, this recursion. What is the recursion? So that r result equal to, I'm saying n into factorial of n minus 1 means what? 4 into, sorry, if I pass 5, this 5 into factorial of 4, 5 minus 1. Means here if you see, this is a caller inside the function itself. It is not outside. Here I might put one caller outside here if you see here. For one time. First time, I might call the function from outside, from the main scope. Are you following? But after that, once the control comes to the function and the execution starts, the function will call by itself. You see here, it's 5 into factorial of 4. It is a caller by itself. I have a function call inside the function itself. And what do you call this? You call this as what? What is this? What do you call this, gentlemen? Recursion, function calling itself. You put a caller inside the function itself. Now what happens for first time? It becomes 5 into factorial of 4. Now when you say factorial of 4, again the control comes to the beginning of this function, and this value which is 4, which is parameter here if you see, that is passed as input in the next iteration. Then again same story. It will check whether n is 0. No, 4 is not equal to 0. Then it will come to else part. Then it will say 5 into 4 into again factorial of 3. You can see here the execution flow. 5 into 4 into means 20 into factorial of 3. Again, you are calling this function. And you are passing 3 as a parameter this time. It's not 4, this time it's 3. Again, it will check is n0 3 equal to 0. No, then it will go to the else part. Again, 5 into 4 into 3 into factorial of 2. Again, factorial is called. This time 2 is passed as value. Again, 2 is 0. No, it will come to else part. Again, 5 into 4 into 3 into 2 into 1. Okay, you can see here factorial of 1. Again, 1 is passed to this function. Is 1 0? No. Again, 5 into 4 into 3 into 2 into 1 and again factorial of 0. Now it will see is n0? Yes. Then it will return 1. When I say return 1, automatically what happens? In place of color, this 1 is returned and the execution stops there. Now what is that? You get output as, what is the output you get here? You got it as 120. Let's check this. I can write this code, sir. Don't worry. Don't think I cannot implement algorithm. I can do it. But just, to save some time, I'm copying and pasting. Then what is that? Factorial of 5. This returns some result actually, because it's returning a value here. The result, final result is written back to the caller. So what you do, put it to some variable, print the text, print. Say that factorial is command x. Then run it. I should get, I'm passing 5. I should get 120. Yes. Suppose if I pass 6, it should be around 720. Okay, perfect. If you pass 8, you should get some other bigger number. Perfect. Okay. So that's how we implement what? Recursion. Got it, right? Any questions? So here, what is the point? Recursion is something in which a function calls by itself. Here, the advantage is there is a number of frequent control jumps, but that is happening within the function itself. You are not moving out from this calling function to this caller here to here, but the control is happening. This control jumping is happening within the function itself. So that what happens is a lot of performance support will be there. Actually, we have a lot of performance increase here with kind of recursive functions. But the point is, when you are going for recursive functions, you should be very careful because you should know how to stop it, where to end the recursion. That is very important. Otherwise, it's very difficult. Again, it leads to infinite loops. When function is in infinite loop, again the stack will be full. Okay, you get a stack error. Okay, you have to be careful with the recursion. That's it, guys. This is the idea about recursive function. I think we took some time to understand it, but still, it is very useful for you to understand how this recursion works. So anyhow, leave this aside, not an issue. Because we got idea about this. This is a simple function about how applying a global that's all within a function, not an issue. Anonymous functions, one of the very important topics. This is very important topic. Anonymous or lambda functions. No, when I was doing an interview for switching my company, so when they asked about Python, this is one thing they asked about me is anonymous functions. I still remember. People may ask you about recursion or not, but people might definitely ask you about lambda functions because one of the very important topic is lambda. So what is an anonymous function? It's a simple thing. It's like any other function, but it's a function without any name, anonymous, no name. Sometimes we say anonymous call means they don't say who they were and they keep calling you. That is called anonymous call. Anonymous function, a function without any name, such functions we call it as anonymous function or lambda functions. The advantage of anonymous functions is you can just insert a piece of code wherever you want when you are implementing a business logic or any kind of logic, not business, it might be some other logic. So these are very useful, and these are just these functions are implemented in a line mostly, just in a line. That's all. If it is a function, you can write many lines of code inside a function. But if it is anonymous, usually anonymous functions are implemented in a single line. You don't need so many lines here. And usually, anonymous functions are declared with the lambda keyword because anonymous functions are nothing but lambda functions. For that, we use a keyword called, what is that keyword? Lambda. What keyword we use here? We use a keyword lambda. Okay. Then let us, what is the syntax of lambda function? So I told you clearly, they are expanded in a line. Second thing is, if you remember, if you are from C++, I'm not saying it is exactly the same, but if you remember C++, if you have idea, if you don't have idea, nothing to worry. Understand from what I am discussing. If you remember, if you have idea, in C++, there is something called inline functions. They are just declared in a single line, maximum two lines. You know, similarly, here also lambda functions are just implemented in a line. There won't be two lines for lambda, like inline functions. Okay. So the advantage I told you, these are used for instant purpose wherever there is a short logic should be implemented. There we use this lambda functions, very useful functions. Okay. So next, the syntax look like this: lambda space parameter list. The first one is parameter list, then the second one is expression. Maybe if this syntax here, it gives you a better clarity. Lambda space parameter list, then expression, business logic. Sir, I want to find a simple program. I'll just show you. How simple lambda functions are. I want to find sum of two numbers, sir. I have a function like this. You know, I think you are good with functions, sir. How do you find sum of two numbers, sir? You have to pass two values, sir. Here, if you see, there are two values A, B. For this, you have to pass two values, sir. Yes, sir. Now, you find the logic and you return it. You can do it. Well, you can do one thing. Either you can assign that color, this is a color, to some variable, or you can pass it to print statement. But remember, sir, a color can be passed to a print only if function is returning result. The function is not returning result, and if you are passing it to a print statement, okay, then it is not useful to you, sir. I think the function returns none, I hope, NONE. We'll check it, sir. But anyhow, first of all, I'm just showing you how to implement a program without Lambda. Same program, we will convert to Lambda function and see how simple it is with Lambda function, which we have implemented with the non-recursive function. Okay, just copy this, come here, run this, sir. Remove all this. I think you got clarity about all this, sir, right? Now run this, sir. Run. Okay. You get 30, sir. It's perfectly fine. Suppose I am not returning results, sir. I am just printing C. Okay, save the program, sir, and just print it. Here you have to put this in parentheses. This is Python 3x, right, sir? In Python 3x, print needs parentheses. In Python 2x, print doesn't need parentheses, sir. Not necessary. Let me just run it. You got none here. I told you, sir. One thing. Before going to talk about how this can be again converted to a Lambda function, how the same code we can implement it in Lambda. How can we simplify it? If you see, you can pass a caller only if the function is returning results, sir. Otherwise, what happens? By default, if it is not returning, then you get something called none. None is equal to null in Java or C sharp. And you have to filter such values, sir. There is no use of none here. No use in sense these are just basic constants. So whenever none, you have to validate nones. Make sure you clean code whenever you are doing such coding. Okay, that is fine, sir. Now the same thing, how I can implement it for Lambda? That is my question, sir. Sir, first you remember the syntax. You don't need to be expert in coding. Understand the syntax, apply the syntax, sir. When you keep applying syntax, automatically you understand that functionality. Okay, and logic that will improve only with practice, sir. You know, see, initially, even if you are not that good with logic, when you keep on doing programs, when you keep on solving problems, anyone can improve logic because we have common sense by birth itself. So I am writing this code, rewriting this code for Lambda. Following, sir. What is that? Some x equal to Lambda. You know the syntax, sir. Follow the syntax, sir. If you don't have idea how to implement Lambda function, see Lambda space list of arguments colon expression. The program which we are writing is a very basic program, sir. There is no complexity in this. LAMBDA colon, sorry, sir, space. I want to find sum of two numbers with Lambda function, sir. Can I do it? Yes. How many parameters are required? To find sum of two numbers, two parameters that you define first, sir. List out all the arguments which you want. Okay, that in the beginning itself, followed by colon. Now what you have to do, sir? You have to implement a business logic. To find sum of two numbers, the business logic is just a plus b, sir. Variable names are your choice. Don't think always we should use ab, sir. You can use xy or you can use whatever you want. But my business logic is what, sir? A plus b, sir. Then after that, over. That's all. See, just some time back, I have implemented sum of two numbers with a non-recursive function with some 3 or 4 lines of code. But that with Lambda, I have rewritten with a single line of code. Can you see this, sir? This time, this function, this Lambda doesn't have any name. It's an anonymous function. This parameters here, whatever we declare in Lambda, goes to what happens? This will be passed as parameters to a function. This becomes parameters in a normal function. And this logic will be declared inside function. Now you see, how do you call this Lambda then? And when you call him Lambda also, you should pass two parameters, sir, two values. Then how do I call it? Don't forget this Lambda has to be initialized to some variable, sir. You see, this Lambda function has to be initialized to some variable like this. So what you have to do, sir? I should call Lambda function through this reference variable. I cannot call Lambda directly, sir. Of course, Lambda automatically internally it will return one value, sir. Okay. But how do I call Lambda? I can call to this through this reference variable. How? Just some x of some 1 comma. Okay. But anyhow, if you should print it right, this will return a result. Either initialize it to some variable, sir, or what you have to do, or you should print it directly through printer. Print of what, sir? Sorry, print of R. Just run this program, save it, run it. Got it right, sir? 3. So this is Lambda or anonymous function, sir. See how beautiful this is. We are just writing a code in one line, sir, not more than one line. Following, sir. That's what the advantage of Lambda is. We can implement program in just a single line of code. Okay. That's why they are useful. We can implement it them in a single line of code. Right. And where these Lambda functions are really useful in our Python. Of course, you can use it in a number of use cases. What can I tell? You can use it in different use cases. But the very important use cases are there are certain built-in functions where definitely Lambda functions are input for these functions. For example, these are the very important built-in functions in Python, which is nothing but filter, map, and reduce functions. And for these functions, by default, the input is always what is that, a Lambda function. Okay, if you look at these three functions, map or filter or reducer, internally the syntax, if you look at that, it is taking the input as a function and a sequence. This function usually will be a Lambda function. Okay, Sir, you can pass a normal functionals in place of that func. But the point is, more than a normal or a regular function, passing lambda will be much more optimized. It's a much more efficient process. But still, if you want, you can pass a non-recursive functions and nothing happens. Or you can pass even recursive function or a lambda function. We need to pass a function here, any function which implements some logic to implement that map functionality. We'll talk on that. But the best one here is what? It's not non-recursive or it's not recursive, but it's a recommended is lambda. Pass lambda as a parameter in place of that function. Understand? Okay. So this is one of very important topics in the whole functions of Python. Lambda is one of the most important concept. If you don't believe me, you can go and check outside. Okay. In any interview, if you go for a Python interview, you cannot expect the interview will be done without this question. There is a company called State Street, sir. Okay. They had done 3 different rounds for me. One round for Java, one round for big data, one round for Python. They need all the technologies, sir. In the Python round, they asked all the basics. What is the syntax for loop, for each, and all that stuff. And one more area where they have spent some time is lambda functions. I'm trying to tell you the importance, sir, so that you prepare according to that. So my experiences I am sharing. So point is in Python, lambda functions is one of the core and crucial topic. And you cannot expect an interview without this question. Okay, fine. We have done it. There are few more programs. You can try this program, sir. These are all same. They work under the same principle. You can see here, greatest of 3 numbers. What is this? The third example. Example 2 is what we have done. Sum of 2 numbers. Example 3, greatest of 3 numbers. Example 4, greatest of 2 numbers. Example 4, greatest of 3 numbers. Are you following, sir? So here the same thing. You have to pass 2 parameters and just return a if a greater than b, else return b. That is the meaning of this. You similarly, greatest of 3 numbers means take 3 inputs, return a if the first logic is satisfied, else b if the second logic is satisfied, else c. Okay. And while calling lambda function, you need to pass 3 values. Okay. Now, if you see, as we discussed, lambda, we don't need to return any value from lambda like in non-recursive function or regular functions or like in recursive function. And you know, sir, lambda internally returns a value. And we don't need to return a value explicitly. This is point 1. Then second point, if you see, we discuss. Sometimes instead of passing a value as parameter, we pass function as an argument directly to another function. What, sir? Very interesting point. We pass function as an argument to another function. Okay. And such functions we call them as higher order functions. Okay. Passing function as parameter to other function. And here, lambda functions are best choice. Because if I should pass function as parameter to other function, then lambda is the best choice for us. Following. Okay. Then next, other examples. So it's a filter, map, and reduce functions. Okay, when you talk about such functions, very useful, sir. For these functions, definitely lambdas are parameters. These are like this. We'll just check out how this works. Ready, sir? So these topics are conceptual topics, sir. Once we finish this, then when we switch to other areas, then we can start again doing implementation. Okay. I hope you have tested those small examples, right? Which I have asked you. Okay. Finding a sum of two numbers with lambda. Did you test this example? Test it, sir. If not, just take 1 minute and test it. And then greatest of two numbers, test it. And greatest of three numbers with lambda, test it. Take some time and do it, sir. Then we'll switch to the filter, map, and reduce examples. Right, sir? Come on. 1 minute for lambda, 1 minute for, I mean, sum of two numbers, 1 minute for greatest of two numbers, 1 minute for greatest of three numbers. 3 minutes, take 3 minutes and implement the three examples. Then we'll switch to filter, map, and reduce. Do it, sir. Solve these three examples first. Just for a practice purpose, nothing more than that. Somebody is asking a question without using written keyword, how would we use code? I think after that I have explained like how this written value is used. I think Ram is asking that question. Did you get that answer or still you are in confusion, Ram? I don't know if Ram is available. Let me check. Yes. Do you got your answer or still there is a confusion, Ram?
No, Manohar, it's clear.
Okay. Thank you. Okay, shall I switch to next topic? So your question is, Shiva, if A greater than B, then A else B. Probably point is, it is expecting return first and then condition check again. Okay, that's how it is manifested. Got it, Shiva? Do you understand my point? Do you want some time, guys? Shall I switch to next topic? Okay, fine, no issues. That's right. Working on this next. How this map, filter, and reduce function work? So these are actually, if you go to big data, these are most very important functions in big data. Okay. Now let's see this map function. Map function means it's simple, sir. So every time when you iterate, it will apply some functionality on each value inside some collection. Suppose if you see, I have a list of values here from 1 to 4, right, collections, and I want to update each value of list by something. Like if you see, 1 should become 1 at 1, 2 should, I want to increment everything by 1, by 100. Then that is done by map function. So what map function does is, map will apply a functionality on each value of a sequence. Sequence in sense it a collection, sir. It might be a list, or it might be a tuple, or it might be a what is that? Any kind of such collections. Indexed collections, of course. Okay. Sequence is that indexed collections. So what I am doing here, every time when I iterate this loop, I am incrementing the value of that I by 100, and again I am storing into the same, okay, same list. And that is this. Okay, got it right? Do you understand the point? Map functionality will impact every value of each value of a sequence. My best example is this one. Following, sir. You can test this sample, sir. Try this example for map. Okay. Try this one. I didn't apply lambda here. This is actually a non-normal functionality. The same thing we do with lambda also. We rewrite this code with lambda. How again we apply lambda here? That we test, sir. As this first example, map function. On each value of sequence, a logic is applied. That is map function. Is it fine, sir? That is map functionality. Then we'll rewrite the same with lambda. We'll see that. But anyhow, before that, without lambda, we are trying to understand this functionality, how it works. Filter. It won't impact every value in a sequence, but filter is applying a condition and trying to get something out of it. Suppose I have a list here, sir. I want to print all the numbers greater than 3. Then I am applying a condition on that here. If I greater than 3, you get all those values. That is filter is doing here. These are all baby programs for you, sir. We have done much more complex programs so far. We have done many programs till now. Okay. Why don't you try this, sir? Test this code now. If not greater than 3, you can print all the numbers less than 3 also. That is one kind of filter. Or printing all even numbers from that sequence. That is one kind of filter. Or printing all prime numbers from that sequence. That is also one kind of filter. Means filter is nothing but applying some condition on a sequence and getting the all the values which will satisfy that condition. Got it right? Test this filter now. That's how filter works. But still without lambda. With lambda, we'll see again. Now I am showing you the raw code for you. Test it, sir. Will finish, sir, all of you. Shall I switch to the next one? Reduce. Shall I switch to reduce or want some time, sir? Any yes or no? Okay, next one, reduce. Reduce as name says, you see, you have sequence of values. All these values should become into a single value, one result. That is reduction. 10 values should become one. Suppose I need to find sum of all these numbers. That is a reduction, or product of all these numbers. That is a reduction. Okay. So if you see, you know how to find sum of n numbers, right? Sum logic. That is actually a kind of reduction examples. Okay, test this. This is what reduce function does. Map function will apply a logic on every independent value in a sequence. Filter apply a condition on every value, and based on that you get output. Reduce will perform what is that all your values are converted to a single result. It will perform apply something on all the values and you get one final result. Okay, either it might be sum or might be product, something like that. That is what reduction is. Might be subtraction. Okay, test it now. Then we will apply the same with the function approach. And first we understand the behavior of how this all these three function behaves, the internal behavior without applying them directly. Now we are going to apply this map function, reduce function or filter function and see how they work. So first test this simple example. said this is fun, done, right? Next one. We'll see here how we can apply a filter program or map program or reduce program by using the built-in functions. So this is a now we are directly using a built-in filter to perform filter operations. So what this filter function does? We can use filter function to filter values from the given sequence based in some condition. Based on some, not in, this is a type, based on some condition. We had discussed that clearly, but without using applying filter function directly. Now, if you see what we have to do if we should apply a filter, the filter has two parameters. This is a built-in function, sir. We are not creating it; it is already there. Maybe you can recreate it, a customized filter, your own filter. It is a different story. But now I am not talking about customized filter function. I am talking about built-in filter, which is already there in the Python API. Okay? It takes two parameters, a function and a sequence. Sequence is any indexed data structure. It might be a list or tuple, and here function is something, the functionality which we need to apply on the sequence. That if you pass it, that iterating each value and applying condition, that is done by the filter itself. You got it right? It's like doing a cooker job. What do you do? Suppose you want to cook some biryani, you put rice in that, chicken in that, all the ingredients in that. What cooker will do? Cooker will all them mix them well and give some water. It will give you the final output, isn't it or not? That is these functions are doing here. They will mix well, but for that the inputs you have to provide. Are you following, sir? Following. Okay. Next, see this now. So here, now if you see, we have a function here. First, we should define. I want to print all the even numbers, from this. Can you see? From this list of values. For this, I have to break down this code into two parts. First, we have to create a function which applies that logic. So we have done such programs in the very beginning. This function is nothing but is even. You can name as you like. I put it as is even with one parameter x. Then what happens? Every time when value is passed to this x, it will check whether it is even, return true, otherwise return false. Are you following, sir? So don't say print x or print y, just return some boolean here because filter expects a boolean value from this function. I think you are good, right, sir? Before you start using filter, first you have to prepare one function like this. Okay, are you following or not? Before you start implementing filter, you should prepare one function like this. Same thing like cooking example. Isn't it or not? When you cook something, put it into a cooker. First you mix everything properly and then you put it into the cooker. That is like this. Prepare a function like this which implements the required business logic. Okay. Then on which source you apply this logic? The input source. What is the source? So prepare one list for that. Now you have both the inputs. You have the function to implement. You have the input to pass. Now you give those two to the filter function. Now, as discussed, filter takes two parameters. One is function, the other one is sequence. Function is this one, sir. Okay. Sequence is second one. Process is same almost for remaining also, but business logic changes. This is non-recursive function. I am not using lambda. This is a regular function. After that, again we rewrite the same code with lambda also. We are going in three. See, we have broke down this learning into three phases. First phase without even using any function, understanding the logic directly. Second phase, applying same logic with function using filter but without lambda. Third phase, how to rewrite the same with lambda. You got it right? So if you have observed carefully, definitely you will get a perfect picture or a clear picture about this function, how filter works, the behavior. Now here, of course, I applied a casting here. The reason is simple. I'll just show you here. You might, I'll write a code for this and show you filter here. See, maybe. So first you have to do in two ways. The filter has two parts. What is that filter of? It takes a function as parameter and a sequence as parameter. So for that, what we should define? First, I have to define a function which implements business logic. My list is this. So my list is some random values 1, 2, 3, 4, 5, something like this. Enough, no problem. We don't need so many. What I need? All even numbers. First, define a function to check whether every number is even or not. What is that? Def, you say is even. Okay. Take one parameter x. So you must and should take a parameterized function here. And for that, you need one parameter. Now, if x percentile 2 is 0, then return a boolean. Don't forget to return boolean, return true. Else, what's it? Else, return false. Or now you apply this to filter. You say some x equal to some filter of. You need to pass two parameters. The first one is a function is even. The second one sequence li. We are done, sir. This is how we have to apply filter. Now you print x. This x should have all the even numbers. But what this filter is doing? Every time what happens is it will internally iterate this list value by value. Every time what it will do, it will extract one value from the list and pass it to this function, get that result and preserve that result internally. Actually, I have to do that. Who should do that? If I don't use filter, I have to manually write a code for that to apply this filter. Filter will iterate this collection value by value, and then that value is passed to this function, and that function returns true or false. Following, right? Whether it is even or not. I have to do that. That job is done by the filter itself. Let's run this now. Then, when you look at the result, you might be wondering, for surprise, we didn't get what is that? We didn't get the values. We got some object. We got a filter object here. Then you might ask me a question: where are the values? Values are there inside filter, sir. Where are these values now? They are there in the inside that filter object. Now you should iterate that filter object and you should print it. That is one approach. Otherwise, if you want that values, that whatever the values that are there in filter, the best approach is apply a casting, then automatically you get the values. See what you can do, apply casting like this. Some list of, I will talk in all the different angles, sir. I told you 360 degrees, people say that. Even you can watch these statements in movies also. Now if you see, you got all even numbers are not right, sir? Yes sir, no sir? Did you get even numbers or not? 2, 4, 6. Are these even or odd? Perfectly even numbers, sir. Do you have any doubt in that? Okay, that is one approach. If I don't apply casting to list, how can I get them then? Okay. Other approach is, you learn this in the very beginning, sir. Just iterate that filter function, sir. For I in X. Okay, print I. We can also print X, but print it first. Save it. Run it. Got the same output? Suppose, sir, I am going little deeper. I am not applying filter function. Without filter function, how can I perfectly how can I perfectly do this without using filter? How can I do this? What is that? Even check on this list of values. How can I even check on list of values without filter? For some time. This we are done with filter, sir. Actually, this is how filter works. We need two inputs, a function. Okay. So we are done with this, right, sir? Okay, got it right. Now I'm going little deeper. How can I do the same program without applying filter function? Remove this. Now you know you got idea, right? We need two inputs, one function to apply business logic, one input source, and this function is applied on this input source. And that is done with filter. We know that, and we got some filter object altogether. And if you iterate, you can get the output. Or if you apply casting to list, then you don't need to do iteration. You get output in the form of list. We have seen each and every step very clearly. Okay, if you have doubt, this is recorded, right? You can do to and fro, to and fro, to and fro from 10 times also. No need to worry about it. One time recording is equal to 1000 or 1 lakh or 1 crore times of what is that? You can go and check to and fro, no problem. Now remove this. How can I do the same filter without using filter function? Again, this like this. First, you need to for I in li colon. So what should I do now? I don't need to directly check condition because there is a function I am using for that. Okay. So what should I do now? So I have to pass every value of I to this even function. So is even of I. Okay. I'm just calling it directly and initializing the result x here. X equal to is even of I. I'm doing a calling here. Then what I'm doing saying print of x. Okay, print of x. That's how I need what is that? I can get all the condition checks. Now let us run this code and see. Is this loop is doing what is it is doing? It is iterating the list. Every time it is passing the value of I to this even function. And if it is satisfying that, then it will return that result something. If it is even, it will return. If it is false also, even if it is not that, it will return something. Now I got x here. Let's first see what do I get in x now. Let me run it. I got all the values, false, true, false, true, false, true. But we need to tune the output now. I want only trues, I don't want false. That is first step. If I want only truths, what should I do now, sir? Tell me. Again, I should apply. I should check a condition. What is that condition? If X is true, print X. Means I am applying a condition. If it is true, then only I should print it. Okay? You remember, right? 1 minute. If X is true, is the identity operator. I think we don't use it. We check like this. Instead of that, if X equal to true, this is perfect. Run mode. Sir, I am going, little deeper into the discussion, so that what we are doing is we are just trying to understand the whole algorithm from to and fro approach. You got 1 minute. Let me remove this. Here we are printing X. Don't print this. Leave it like this. Now let's try this. Got all truths? Then immediately somebody in the group might ask me, okay, I will take some random name here. Ayappa just came to the session. So Ayappa might ask me a question. What Ayappa? What do you say? Sir, could you show us instead of true or false true values, I want only the value in place of true. Means you got my point, right? Some value is even. If even it is true, fine. For which value it is returning true, I want you to print only that value. I don't want true, because if true means what, which is true is we know 2 is true, 4 is true, 6 is true, right? Whenever it is even, it returns true. All even numbers returns true. But I don't want the boolean value here. I want the value of that boolean. Then how can I get value of that boolean? You got my point, right, gentlemen and ladies? How do I get value of the boolean? See how much logic is involved again. Understand? See, if you try to understand carefully, if you try to concentrate, there is so much in this. Okay, see now, what can we do? It's an easy thing. Don't print X then. If it is true, print I. Okay. Because what is that? Only in that case, we need to print I. Only when X is true, then only print I. Otherwise, don't print I. Then you get values here, sir. You can see now. Now you get only value. Can you see 2, 4, 6? Perfect, right? Means if I just put filter, I don't need to do all this again. This whole job is done by the filter functions. See, already we are doing function topic. Do you want me to rewrite this code in filter? Do you want me to create a function of myself, a filter function myself? What do you say, gentlemen? Tell me. Yes, sir. Yes, sir. No, sir. Can I just rewrite a simple filter function for that like this? How? Just create, what is that, def filter of what I should take. This take 2 parameters. The function, I'm creating my own function, sir. I'm not depending on built-in. Is even, comma, 2 parameters. Second one is a sequence. So what should I do right now? We need to pass function as parameter to this. Okay. Then what should we do? So now here you should check now. You should apply logic. What is it? For I in sequence colon You do one thing. Same thing. Whatever I wrote just now. What is that? Some x equal to is even. This need not to be is even, sir. This is a parameter. You can make it as even also. Okay. For that we need pass function internally. That function, everything is object here. I will show you. I will show you. See, I'm giving you all the different approaches of tuning code using. See, sir, if you wish to understand in a deeper approach, then it is very good for you, because we are going level by level into this implementation. Okay. Now x equal to is even. Now is even after put I. Then it returns some boolean. Just now we have tested. Then what I have to do again? Again, if x equal to true, if it is true, then what should I do? Then usually we can print what? Print of if it is true, print I. That's all. Because I have to print only whichever the numbers are even. Now run it. Run module. So point is, I need to call this function again. How do I call? A filter of. First thing you have to pass function as parameters. What should I pass? Function as parameter. So filter of is even. Second one, I should pass sequence li. Can you see this, sir? We are passing two inputs to this filter. We have to pass the function itself as a parameter. Second one, this one. I think function has some object again. Okay, let me test it, sir. It returns some result. If you want, you can return, sir. Right now we are not returning, we are printing. We'll see that. Got it right, sir? Suppose I'll put some indication here. Some true. If it is true, then only you should print that. 1 minute. Come on. Okay. Let me just rewrite the code so that you understand whether it is really modified or not. Can you see that, sir? So what I am doing here, sir, you are learning one more new topic here without your effort. We are learning one new topic. Observe carefully. You are also learning a topic called higher order function. Which function, sir? What topic you are learning? See, this is a function which is taking parameter. So far, if function has parameters, we have observed yesterday in yesterday's whole session, passing values, not passing function as a parameter to a function. We didn't see this example yesterday. Today we are seeing, sir. You see, is even is a function itself. We are passing that as parameter to other function, that is to filter. Interesting, right? Such functions we call higher order functions. Can you see it, sir? Following, sir. So what it reads, sir? And we are passing a list as a parameter. Means, see, this is my function I wrote for filter. But you can simplify this. You don't need all these efforts. You can simplify this with simple filter existing function. Pass your function as input to that and just that sequence, and then just initialize that result to some variable over. I have put so much of effort to do all this, sir. Customize the filter, my filter. But you don't need to do this. Python people have already given a filter for us. If you want to just to check some condition, you just pass the input to the filter, sir. That's enough. You don't need to do anything. Just remove this. Okay. Then what? You say some result equal to, this is a built-in function, sir, not my customized function. It is there in the API. Okay. Is even sequence. Okay. If you print it directly, you get a filter object with result inside that. So I have shown this to you. Then the other way is either iterate it and get value by value, or otherwise apply casting to what? List. Okay. Following said. Something is missing, nothing to worry. I will fix it. I know very well how to fix it. The sequence pass li here. My input source is list. I named it as li, so pass li. This time it will work. Are you following, sir? Sir, we are just not learning the coding or the concept. If you have observed from the past half an hour, we have seen, the different ways of, how the built-in function behaves. The algorithm of built-in also we are seeing. So if you are able to understand an application to that level, tomorrow in your project, you can implement things without much effort, sir. I know if to listen to this kind of session, you need a lot of patience, sir, because I'm going step by step into the the core part of the coding. But if you can be patient and understand the behavior and how it's working, and if you can learn all these approaches, you see the result tomorrow when you are working in project, not here. Got it right, sir? Understood now? So I have just only shown you how this filter works. Same thing, mapper, same thing, reduce behaves. In similar way, you can customize your own map function. You can customize your own reduce function. You have to think always from the level of algorithm. See, 70 to 80% of the developers, they just only know how to apply at the top level. They don't know at the ground level. But if you can go to the ground level and if you understand the behavior, then you are something else, sir. Trust me. Next one. So you can try the remaining also, sir. Let's just switch. Now let's apply lambda. Still we didn't apply lambda. We have applied what without lambda. How can I simplify this again? I am going to comment this whole code, sir. I'm commenting it. I'm putting this in comments. Now I rewrite this code with lambda. Just now we have seen how to write a lambda function. Okay. Triple quote, sir. Comment in Python is a multi-line comment is triple quote. That code is ignored now. Now here means we don't have even function. I am rewriting it directly like this. How lambda space list of parameters. It takes two parameters, right? Lambda space li colon 1 minute, guys. 1 minute. Sorry. Okay, let me pass it like this. Li colon is given. So we can see simplify the code directly like this. And of course, do you have a easy even function now? I am passing easy even, but do you have that? Tell me. No, right? Let's remove this. X colon if x percentile true equal to 0. That's all. I have to directly implement that even logic, sir. I don't have even function, right? Now we are directly writing that even logic with rewriting that function with lambda. That is what the purpose of lambda is, right? Instead of writing multiple lines of code, I have 5 or 6 lines of code in even that I rewrite that in single line. That is what lambda. That is the speciality of lambda, and this is the first input. First argument is a function as argument. I directly pass lambda now. Instead of writing a function and instead of passing that as argument, I directly pass lambda as argument. And the sequence which I should pass as input, that also as second argument. Now what happens? Let me run it first. Do we get the expected output or is it going to give me some? Okay. It's showing that error here. Okay, I'll do one thing. Let me remove this if here. Let me test it. Not an issue. We get output, sir. Got it right? Even we don't need to apply if there. You can directly pass the expression, your parameter and your expression. It takes two parts, right? Lambda. Following, sir. Are you following? See, if you have observed the different levels we have done so far, the stages, we have brought this to this stage and we understood how the inner algorithm behaves, the filter algorithm behaves. How, if you want to customize it, how you can customize that. You have seen all these methodologies. Following, sir. So now if I run this, I got the expected output. What's happening here? Some of you might have a bit of confusion how this is working. You might know this logic. This will check whether x is even. What's happening here? What filter is doing? Every time it will iterate list, sir. It will get one value from list. Pass it to this lambda function. X. It takes x will hold 1. This will check whether it is even or not. If it is even, it will return true. Again, second time. It will iterate one more, it will get one more value. Pass it to lambda. Check the condition. But it will just only consider the true values, not the false values. If it is the if it gets any false, it will ignore false. It will take only trues here. Are you following this? Filter will just only filter based on the Boolean true, not Boolean false. If it is false, it will ignore false, but it will consider true. Are you following? Yes or no, sir? Give me something in the chat box, sir. Are you following? Okay. Somebody is saying this is not working, sir. What is not working? I will check it after at the end, Shiva. Okay. I will check it with at the end. Okay. Shiva has written some code and he's doing there something. Did you write a customized code or are you depending on built-in function, Mr. Shiva?
I just used append function instead of list constructor. The remaining is same.
You are depending on built-in function, right? Built-in function will return all the group of values as an object. Okay, not just one value. Append is applicable when you return object by value element by element. Okay.
Okay.
When should we use append? If you want to add value by value to a list, then you have to pass call append. But this filter, first it will apply the whole logic and finally get all the entire result, and that result is put into one filter object. It is not
Okay.
element by element. Filter don't return element by element. It will give you the whole output in one object. Okay.
Okay. Got it. Got it. Okay.
There is no point of using append here. Append is required when filter returns element by element. Okay. But filter is not doing that, right? So I think he got the answer. Now, what happens here? It will iterate element by element, pass to lambda, check it is whether it is true. Then finally, it will collect all the results into one object, and that is returned. I have shown clearly. It will return filter object if you don't apply casting to list. If you apply casting to list, it will return list. If you don't, you have to excuse me. You have to iterate element by element. Is it clear, right? Some filter gives object, so we need to convert with the type if you want to append. No, it's not like with the type to append. I think just now I have explained, right? I think it is G. I don't know who is G, but still, okay, got it. Fine. Do you get clarity on this concept first? Because this has different layers. Today's discussion, I think this is, I can tell this is one of the best session I have done so far. From my side, I'm telling you, might be, I don't know how much you learned here. Throughout my teaching career, this is one best session I have done. Okay, so clear, right? Now next, we can go to the next one there. This is about filters, sir. If you have questions, you can shoot me. You can, there are people, asking me questions. I will definitely follow up your questions. Next one, map. You can try remaining, sir. We can see it in the next session. Okay, I have some work. Already we have done more than 1.5 hours today. I thought to come to up to 12 or 12:30. Have some work, sir. After this, I need to implement one small project. Okay. So shall we meet next week? Keep attending sessions, sir. Push your friends also to come to these sessions. These are free sessions, sir, but useful for you more than me. For me, they are very useful to you, sir. So what I request is, if possible, if any of your friends were interested in this Python, push them to these sessions, bring them, drag them. Okay. Any questions, sir? And the big data part, about fees thing. Some of you are asking me about fees. You can negotiate, sir. Don't worry about that part. If you are really interested to learn big data, you can come on. We can talk on the fees part. Don't worry. Okay. Any questions, sir? We'll talk about this map and reduce in the next session. At the deeper level, we'll see, try to understand it. Okay. Then we'll close this and switch to the next topic. What is that next topic? Files. We will also do a lot of file programming. Then we are done with core Python. So far, still we are hanging in core Python. Still in core Python, there are many things to do. We keep doing. It's not like we are going to stop here. I told you, right? If you want to really learn so much of Python, keep attending this. If you have questions, ask me. Otherwise, we'll discuss in the next week. Okay. Thank you.